Welcome back. At the end of the last lesson, I asked you to go over and look this stuff up yourself. So how do we find the mass of an atom? Oh, I want to quickly re-review isotopes. So carbon-12 has 6 protons and 6 neutrons. That's where it gets its mass number of 12. 6 plus 6 is 12. Carbon-13 has 6 protons because it's carbon. And remember, the proton is the atomic number, so all of them have the same atomic number. They're all 6 protons, they're all carbon. Carbon-13 has an extra neutron, so its mass is 13. 7 neutrons plus the 6 protons has a mass of 13. And carbon-14 has still 6 protons because it's carbon. If it didn't have 6 protons, it would not be carbon. But it has 8 neutrons, so its nucleus is a little bit heavier. 8 plus 6 is 14, and that's where this mass comes from. So in the world, if we add up all the 12s, plus all the 13s, plus all the 14s, well, the average is going to be a little bit above 12. So that's why we see this as being 12.011. Okay? It's because there's just a tiny amount of 13 and a tiny amount of 14 in the world. Okay? This big number on the top box of the periodic table, this 6, is the atomic number. It tells us the number of protons. So like with this carbon, okay, carbon has an atomic number of 6 and it has 6 protons. This big letter in the middle of the box is the element symbol. Okay, and then this is pretty obvious, carbon, that's the name of the element, it's the element name. And this box at the bottom is the average atomic mass. Okay. We're going to round this off to the nearest whole number whenever we use this. So whenever we do anything in class, we would be using carbon-12 because we're going to round this off to 12.0. Okay. How do we find the atomic mass? Well, how do we find the mass of an atom? Okay, it's the protons, like I was just explaining, plus the neutrons. So 6 plus 6 is 12, or 7 plus 6 is 13. And then what is the atomic number? The atomic number is equal to the number of protons. Okay. Now, this is a really important page, and we're going to go over a lot on this page. Okay. So we're going to get our money's worth out of this little diagram. This would be a good thing to label carefully and then refer back to, okay, because I'm kind of going to explain all the nuts and bolts of the unit here, all the important things. So if you don't get all of it this first time, don't freak out, but this is going to be a good page to reference back to. Now, this is a Bohr model of an atom, so we can see that it has the nucleus here, and then it has this energy level, where the electron is going around here that shows 2 of them on this first energy level. And then there's this second energy level with 2 electrons on it. So the electrons have a negative charge. That's why it shows this minus inside the little circle. It shows in the nucleus, the protons have a positive charge. There's 1, 2, 3, 4 of them. The neutrons are neutral, so there's no charge. And that's why their circle is clear. There's nothing in there. So we have these positive charges. There's 4 of them. We have these negative charges, there's 4 of them, and remember we said the atom is neutral because positives cancel out the negatives, so this positive could cancel out this negative, and this one would cancel out that one, and so on, and they would all cancel out. The overall charge of the atom would be 0. Okay. There are 2 electrons on this first energy level. Now, as a matter of fact, the first energy level can never hold more than 2 electrons, so it's full. And then I wanted you to notice that there's 2 electrons on this outermost energy level. These are called valence electrons. Now, in this whole unit, these are the ones that we're going to be concerned with because these are the ones that determine the properties of the element. It determines how it's going to react in chemical reactions. It determines what family it's going to be in. So these are the ones that are really important. Okay. 2 valence electrons tells us the column the element is in on the periodic table. So because there's 2 valence electrons, we would expect the find this element in column 2. And there's a total of 2 energy levels. There's this first inner energy level and then this second energy level. This tells us the row or the period the element is on. So we would expect to find this on period 2. So the columns go up and down and the rows go across. Okay. This element has an atomic number of 4 because there's 4 positive protons. Remember, protons, the atomic number tells us the number of protons. It's really kind of like a synonym. Okay, so there's 1, 2, 3, 4 positive charges, so the atomic number would be 4. The number of neutrons is 5. There's 1, 2, 3, 4, 5 particles in the nucleus that have no charge, so those are neutrons. So the atomic mass of this element is 9. We have 4 protons plus the 5 neutrons, and the atomic mass is what's in the nucleus, so 4 plus 5 is 9. So here it is. This is beryllium. Beryllium has an atomic mass of 9. It's kind of small. This is 9.0121831. Here in the corner, remember we round this off to 9 because beryllium must have some isotopes. It has an atomic number of 4. Okay, so you know it has 4 protons. There they are. Okay, we know the mass is 9. How could we find the 5 neutrons? Now the reason why I ask this, and I put this here, is this is the information that you're going to be given on the periodic table. You're going to know the 9 and you're going to know the 4. So how could we find the 5 neutrons if this is what we saw instead of this model? Well, we can take the atomic mass, which is the 9, minus the atomic number, which is the 4, and that would equal the 5 neutrons. 9 minus 4 is 5. Okay, so here's some things that we've learned about the element so far. We know the element should be on the second row or period of the periodic table because there's a total of 2 energy levels. We know that the element should be found in column 2 because it has these 2 valence electrons. And we also know that the atomic number is 4. So here's the periodic table. The atomic number is 4. So this element should be beryllium. But we also thought it should be on the second row, and we thought it should be in the second column. The rows go across, so hydrogen and helium are the first row, and the second row is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. So here we see it is on row 2, just where we thought it would be because of the 2 energy levels. We also see that it's in column 2. The columns go up and down. So this is column 1, and this is column 2 right here. And there we find it, right here where the 2 meet. Okay, where column 2 and row 2 meet, right here. And we see that it is beryllium. So there's a couple of ways we identified what this element should be by its valence electrons. There's 2 valence electrons, so it's in column 2. The model had 2 energy levels, so we know it should be on row 2. So what that tells us is every element on row 2 has 2 energy levels in its model, just like that model of beryllium behind the periodic table. So lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon all have 2 energy levels. And what we also know about these columns is that every element in this column would have 2 electrons on its outer energy level. So what's similar about beryllium, magnesium, calcium, strontium, barium, and radium is that they all have 2 valence electrons, 2 electrons on that outermost energy level. Okay, so here's those 2 electrons on the outermost energy level. They're the valence. Here's the 2 energy levels. So the 2 energy levels tell us the row going across. The valence electrons tell us the column going up and down. So at the bottom of that page, I put the top over here so we can refer to it a little bit when we fill this out. So the atomic number is equal to the number of protons in the nucleus. So what's the atomic number for this atom? Well, we said it was 4, because there's 4 protons in this nucleus. The atomic mass is equal to the total of protons plus neutrons in the nucleus. So over here we looked and we said there were 4 protons and 5 neutrons, so the mass of this atom would be 9. So for this atom, the mass is the 4 protons plus the 5 neutrons, so its mass is 9. And you notice I'm using the same colors as I used up here. So we know the mass number, which is 9, and we know the atomic number is 4. So how many neutrons does the element have? Well, we counted that there were 5 in this diagram. So we need to look at the relationship between the 9 and the 4. This is the information we're going to find in a box on the periodic table. So what would be the formula for finding the number of neutrons? Well, if we know the neutrons for this one is 5 because we can count them in the model, the relationship is the mass, 9, minus 4, which is the atomic number, equals 5. So what's the formula for finding the number of neutrons? We take the mass, which in this case is 9, minus the atomic number, which is 4, and we get the 5 neutrons. So I put down our specific case, atomic mass 9 minus the atomic number of 4 equals our 5 neutrons. And this is important because you're going to be asked to, for different elements to find out how many neutrons there are, and it's not specifically listed here in a box of the periodic table. It is something you have to calculate. And it says, how can we determine the number of electrons in an atom? The number of electrons in an atom is always equal, the negatives are always equal to the positives. And the positives are the atomic number, the protons, so the number of electrons negative is equal to the atomic number of protons positive. And this makes the atom neutral overall. Okay. Now in our next lesson, we're going to pick up with a little discussion of the periodic table. So I want you to go over your study slides, and we'll pick up here next time.